So, yeah, make it quick. I'm almost running out of... Damn it. Why are those things always running out of battery when you need them? Why are they so inefficient? Or actually, are they inefficient? Today I want to put a few things about energy and power into perspective. The battery in an iPhone is rated as 1400 milliamp hours. That's 5040 coulombs, or the same charge as 31,000 millions of electrons. I counted them twice. It's 5.2 watt-hours, or 18,700 joules of energy. Confusing, isn't it? What does that actually mean? Well, it means that your iPhone could run for 50 days on a single flapjack. Now, it's true. A flapjack has 250 kilocalories, and a sedentary adult would need 8 of those to survive a day, although I wouldn't recommend such a diet. Paula Radcliffe in a marathon would run around about 20 minutes on one of those. So, actually, this is a remarkable achievement in terms of science and engineering to power a device that essentially has more computing power than NASA uses to shoot a rover to Mars, and that most people actually use to shoot birds at pigs. So, did you know that on your electricity bill, charging your iPhone for an entire year will only amount to about 12 to 15p? It's actually not much. So, I hear you say though, why does it take so long to charge? Couldn't I have the equivalent of a sprinter in my phone, essentially? Well, capacitors do exactly that. Holding a capacitor in your hand is like keeping a lightning bolt in a jar. I mean, the ones from Sky, not the one from Jamaica. And I'm exaggerating a little bit because a lightning bolt equates to about 5,000 flapjacks. But the point is, capacitors have a really high power density, and they charge and discharge very quickly. They are very similar to Usain Bolt in a sense. Usain is really, really fast, but he runs out of steam after 9.58 seconds. Luckily, scientists are nowadays looking at graphene, which is essentially the same material that you're using in your pencils, to make the next generation supercapacitors that combine the advantages of high energy density of batteries and high power density of capacitors. And essentially, this would solve the problem. Now imagine Usain Bolt being able to run a marathon at full pelt. He would be done an hour earlier than Paula Radcliffe. And so essentially, I think in a few years' time, this 3-minute talk would be plenty enough time to recharge my phone.